Alright, James here. Now in this video we're going to have a look at these two LED bulbs. Now these were actually given to me by a customer of mine, and she brought a load of these online, and these two have actually failed. Now apparently they lasted about 8 months, and one of them has completely fizzled out altogether and won't switch on, and the other one has developed a nice case of disco fever and it's flickering and strobing and doing all kinds of crazy jazz. So I did say to her, look, it's been less than a year, why don't you just send them back and get your money back? She said, to be honest with you, I can't be bothered with the hassle. They were cheap enough anyway, I won't be buying any more. And so she's donated these to me so that I can tear these apart and try and find out actually what's gone wrong with them. Now I'm a bit more excited about tearing apart the flickery one, which I think was this one, I can't remember. The one that just doesn't switch on is probably going to be boring. It's probably going to be a blown resistor or something. But either way, we're going to get these on the bench, take them apart, and we're going to look at these a bit more closely. So here's the bulbs in question. Now they look like fairly generic, typical kind of candle LED bulbs that you'd find online. They don't look too bad. I've seen better, but I must admit I'm a little bit of a snob when it comes to lighting products. If they don't look the part, I'm not generally that interested, but these don't look too bad. Obviously the reliability is a little bit to be desired. Now there's actually no information or markings on here, but apparently it did have a packaging, but she couldn't find it. It doesn't matter, we'll suss it all out as we go along anyway. Now I'm expecting, I don't think there's going to be anything in the top part of this bulb. I think this is just going to be a diffuser, and the main part of the LED construction is going to be down the bottom. Now I'm thinking that it's probably going to have these generic high-powered LED chips, maybe 3, 4, I don't know, I think it's maybe a 4 or a 5 watt. So I think it's going to have those on a little aluminium plate, similar to the GU10 LED bulbs. Okay, let's actually give these bulbs some power and see what they do. Now, yes, this looks very dubious, and yes, this is live, but believe me, this is not connected directly to the mains, okay? This is actually isolated from the mains. Look, I'm touching, look, no shock, okay? So this is isolated from the mains, it's not referenced to earth, so no current will flow through my body, okay? So don't panic, don't, start leaving comments saying, oh, you're an idiot, you're going to kill yourself. Trust me, I know what I'm doing. Right, anyway, so let's power these up. Okay, that's obviously the one that wasn't working because nothing's happening. And this one, yep, that one's, well, it's very dim and it's all flickery and it's making quite a loud buzzing noise. I don't know if you can hear that. Yeah, that doesn't sound very healthy at all. So that's the one we're going to take apart first, I think. Well, let's actually take these apart then and see what's inside them, and then we'll try and work out what the wattage was supposed to be before they actually failed. Now, I can see there's actually a load of silicone around there where it's stuck in, so I'm guessing that is just going to pull off of there. The only thing is, that is rather thin glass, and I'm a bit worried that if I start twisting and pulling on that, that's going to shatter and I'm going to end up impaling my palms of my hand with glass. So I'm actually going to put some gloves on to do this because I don't fancy impaling my hands with glass. I know impaling yourself with glass and cutting yourself open is all part of the fun of it, but I need these hands for work, so I don't fancy that. Now I reckon if I start twisting and pulling, that is actually going to break the silicone there and hopefully will come apart without shattering the glass. Ah, there we go. Okay, yeah, wow, that is very thin glass, so I didn't trust that one bit. Right, gloves off. Actually, I've got to do the other one yet, but I'll do that in a minute. Is that actually glass or is it plastic? Let's have a look. Yep, that's glass. Yeah. So, yeah, that could have quite easily shattered, so I think I was quite wise to wear gloves. Okay, so as I suspected, all of the guts of the lamp is down at the bottom here. We've got 4 high-powered LED chips. Now, these are usually driven at about 1 watt, so there's 4 of them, so I think we can safely assume this is going to be a 4-watt light bulb. So let's actually have a look and try and get to the power supply. Now, I don't know whether, I think this might be glued onto here because I can't see any screws, and yeah, they've actually used some kind of thermally conductive glue to glue that on, so it doesn't look like we're going to be getting that off. So I'm thinking, like the GU10 ones, maybe it unscrews from the base. So let's give that a go. Oh, it's moving. So possibly. Oh, hang on. Whoa, hang on. Yeah, something's unscrewing. Oh, okay, that's just that ring there. Right, okay, that's no good. Right, we need to get this base off, really. Might need the aid of pliers. Yeah, I can't see any glue at all. I seriously think that is threaded onto there. I might have to go and get my grips. Right, I've got my grips. Nothing is safe from the grasp of the almighty grips. Yep, there we go. I had a feeling that was threaded. Hooray! Right, we're in. Whoa, okay, not good. Let's have a look. Right, now the first thing I notice is there's some very obnoxious smells coming out of here, and you can see there's a nasty big skid mark on the inside of there, so something's gone bang in there. And the wires are all burnt there, and it's actually got so hot the insulation has become crispy. That's actually crisping and falling to pieces. So that's not particularly good. They're quite close together. They could have quite easily shorted out. Not good. And we can see the heat shrink has gone all crispy from the heat. So right, let's cut this open. Let's snip those off first. Let's cut this open and we'll see. Yeah, there's a lot of evidence of small explosions happening in there. You can see there's a lot of black scorching around this capacitor. Yeah, those diodes have copped it pretty bad. Yeah, there's a resistor on there that's all fried. The chip's probably fried. So my guess is something has gone very horribly wrong with that chip or with the transformer, and it's pretty much put the whole circuit up against a dead short inside here. Come to think of it now, I do remember her saying that recently her circuit breaker for the lighting circuit did trip and she put it down to a blown light bulb. But I think it was actually this, because there's no way that that must have been a dead short to cook those diodes up like that. So I think that this is what actually tripped the circuit breaker. But it's gone open circuit anyway, so the fault has cleared itself. Whatever the fault might have been, whether the chip went faulty or whether there was a fault in the transformer. Yeah, it's pretty bad. Now the main input filter capacitor doesn't look too bad. It's quite a big one actually. It's 6.8 microfarads. It's usually they usually put like a 4.7 in here. That's quite high, but there you go. So yeah, that one's pretty much, that's a write-off. That's just gone bang. So I think the LEDs will probably still be okay, so I might actually desolder them and keep them because they're probably still working okay. Okay, so I've stripped the other one apart in the same way. Now this one doesn't look as bad. It was still, the heat shrink on there was still quite crispy, but the actual lead wires don't look too bad. They're not as crispy. I am gonna snip those so I can get better access. And I'm going to strip these as well so I can join a wire on later on, because I want to power this thing up and see if we can suss out what's wrong with it. Now interestingly enough, this one actually has the slightly more common 4.7 microfarad capacitor on the input. This one has a slightly higher 6.8 microfarad, so obviously these are from different batches, and they probably decided that the lamp works just fine. They don't actually need this much capacitance, so they downgraded to a 4.7. Probably saving themselves a few pence in the process, but either way they've decided that, you know, that's the case. Right, let's start looking into what's actually wrong with this. Now quite a common failure mode for these is that, especially with the GU10s that have this same construction, the 4 LEDs are actually in series, and what can happen is one of them can fail, and it doesn't fail completely, it still allows a small amount of current to leak through it, and that small amount of current ends up going through all the other LEDs, but it's not the full current, it will be a very tiny amount, and then they all just go dim. So the way you can tell if that's the case, we actually short the LEDs out one by one, and if you short out one of the ones that have died, the rest of them will come on, you know, the full brightness. So let's just try that now. Let's get rid of all this heat shrink crispy stuff. Right, so I've got a multimeter here and I've got it on the milliamp setting. So what I'm going to do is I'm going to power this thing up, and I'm just going to short across all the LEDs and see if any of the others come up to their proper brightness. So I'll do that one first. Okay, now that's 20 milliamps, which is nowhere near what it should be. Nope. Nope. No. Okay, so that's not an actual guaranteed method, but it'll give you a rough idea. If you short one of them and the rest come on, then usually that's just a sign that one of the LEDs has gone. Okay, so I'm going to go and get the oscilloscope out, and I'm going to test that and just see if it's actually oscillating correctly. Right. Oh, and do you know what? I never normally forget to do that. I'm just so grateful this meter has a beeper to let you know. I think all multimeters should have that. I know some of them have got the shutters, but they should all at least have a mode that beeps if you've still got it in the amps. Right, so I've got my oscilloscope now. I'm just going to take a few basic measurements. Now, the chip that's used on here is an LS8511. Now, this is a fairly common switch mode controller chip for these little LED modules. Now, I won't bother trying to get a data sheet for this because it will almost certainly be useless. And the reason being, well, here's the data sheet for a similar chip that's used in a lot of LED products, and as you can see, for me that is about as useful as a fart in a spacesuit because I can't read Chinese. And there is a little circuit diagram there, but that's just a typical application. That's not really much use either. So yeah, and you'll find that they're pretty much all like that, and the reason being is because these chips are made by Chinese manufacturers for the Chinese market. These LEDs are pretty much all made in China, so it's pointless mass manufacturing these chips and supplying them worldwide if they're all going to be made in China anyway. So they generally tend to make these kind of chips, these obscure cheap ones that most, you know, local Chinese manufacturers of these bulbs can just get hold of and just, you know, sling in their products basically. What I want to do is just quickly take a measurement between the power supply to the primary side of the transformer and the drain on the chip, just to make sure and see if it's switching properly. So I'm going to power this up, and we'll just take a quick look at the waveform, and that'll give us an indication of whether it's actually switching properly. So it's just easier to take this measurement on the back of the transformer, because trying to put these probes on the pins of that chip is just going to be a nightmare. Fire that up. It is actually oscillating. It's trying to do something, but there's so much noise on there. The oscilloscope just can't really make head or tail of it. Okay, so that could be the chip itself, or it might be an input problem to the chip. I can actually hear the transformer. I can hear a... Oh, hello. Okay, that's doing some weird crazy things now. Right, okay, so let's actually measure the primaries again. Yeah, look at that, it's actually switching properly now. 45 kilohertz. It's a bit unstable though, and there's still quite a lot of noise and ringing on that. Yeah, it's going up and down a little bit. Oh, hang on. Oh, I can smell a slightly obnoxious smell coming from that. I'm going to switch that off actually. Yeah, something smells very hot actually. Okay, it's not the chip, that's barely warm to be honest. The diodes are okay. Oh, wow, that capacitor is really hot. Okay, I think I've just discovered what it is then. Right, so I've got these clips on the capacitor now. I'm just using the scope to measure across it. I'm expecting there to be about 350 volts on this cap, so I'm going to put the range up to 200 volts per division. I'm going to leave the time base on auto. Just going to fire it up and actually see if there's any major ripple on there and see what it's doing over time, because it seems like that's just taking ages to charge up because it's possibly dead, and that's why it's getting hot. So right, let's turn the power on and see what happens. Yeah, that's really not happy at all, is it? That should just be a steady 350 volts, and it should maybe a tiny bit of ripple. That's going all over the place. That's probably why it's getting so hot, because it's rapidly charging and discharging, like it's all over the place. Yeah, it's not very happy at all. I can actually hear a buzzing coming from that, and I think it's coming from the transformer. If I touch that, yeah, it shuts up. Yeah, it has eventually charged up, but there's a lot of ripple on there. It's all over the place. So I think that capacitor's dead. Okay, well, let's actually test the capacitor. Let's take it off the board. Right, soldering iron's nice and hot, so I'm just going to use the whole heat up the 2 pins and yank on it method, because I'm not really bothered about damaging this board, if I'm honest. That's it. Right then, let's see how many of these microfarads have escaped out of this thing. Yeah, that's showing about 900 nanofarads. That's not good. So this capacitor's knackered. So yeah, wow. So pretty much 3.7 microfarads have just evaporated out of this capacitor. So that's pretty much scrap. But that's okay, because we've got a perfectly good one on this other LED, a nice big beefy 6.8 microfarads. So let's desolder this one. And again, I'm employing the whole heat it up and pull on it technique. There we go. I can't be bothered with wicking all the old solder out and putting it through the board, so I'm just going to tack it on the back like this. There you go, tacked on, dodgy as you like. The soldering on that capacitor is rough as arseholes, but there you go. Well, I bet this is going to power straight up now, no problems. Ta-da! There we go, sorted. Right, now the LED's fired up and it's working at its full power, I'm going to take this opportunity to now measure the voltage and current again, and see if we can determine its power output. 12.42 volts. Okay, so let's now measure the current across one of the LEDs, and that is 272 milliamps, so nearly 300 milliamps. So usually these are driven at 3.5 volts at about 300 milliamps, and that gives you your 1 watt, but they're actually underdriving these slightly, it looks like. So give or take, it's about 4 watts. Now, I think the reason why this capacitor actually failed was due to heat. Now, I reckon if I tap that, that plate's going to come straight out of there, like that. So that's basically thermally glued onto this aluminium disc, and then that aluminium disc is just sitting in there. So the only way that the heat is going to transfer from this disc to this outer heatsink is just by a small amount of contact around this edge. And when that's sitting in there like that, if you look inside there, you can see there's all that large surface area back there where the heat is going to come off of, and it's going to build up inside this casing here. Now, they have put some small holes around the outside of this, but obviously that's not enough. And when that is actually together like that, and that's hanging in a light fitting, all the heat's going to rise and build up inside there. And I think that's why that heat shrink in there's gone all crispy and burnt, because of the heat build up. Now, if it were me, I would probably make these heat fins actually protrude in a bit further into the centre of that disc there, and that would hopefully help to draw more heat off of that. And I'd probably put some kind of small barrier in the back here to prevent the heat from actually going up inside this part here where the electronics are housed, and just, you know, allowing it to escape through these holes in the side rather than going up inside there and overheating the electronics, which is what I think has actually happened. So really, I think this is just, you know, a poor thermal design, and I think the reason why they have actually done that is because they've saved themselves, you know, probably a few pence worth of aluminium not making those fins go further in. Thing is, I actually quite like this light. The light output's very good, and if you put the little cover back on, you can see even with that on, it's still very bright, and it's quite diffused. So if you was to use this in some kind of lamp fitting where the bulb was actually exposed, it'd be quite nice, because it's not very harsh on the eyes. It's quite nice to look at. Right, so I put the bulb back together again, and I've got it inside a light socket, and I've got it hanging down as if it would be if you had it inside a light fitting. I've got my digital thermometer, and I've got one thermocouple which is just touching the outside of the heatsink, so that's just going to measure the temperature of that. And I've got another one which is poked through the hole, and that's not actually touching anything in there, it's just floating in free air. So that's just going to measure the air temperature inside the actual lamp. And I've made doubly sure that that's not touching the circuit board in there, because that will give us a false reading. And I've got it to 21 degrees at the moment, which is pretty much room temperature, so it's a good way to start from. I'm going to turn it on, let it run for 2-3 hours, get it up to a normal operating temperature, and we'll see what the temperature is, and I'll see if there's any difference inside versus outside. So let's fire the lamp up and go and make a cup of tea or something. Okay, so the bulb's been on for about 2.5 hours now, and if I can just take your attention to the display on the thermometer, you can see the outside temperature of the heatsink is up to about 60 degrees C. And that's alright, it's not too hot for this type of LED bulb. If we look at the air temperature inside the actual enclosure of the bulb, we can see that's up to about 95 degrees. And that's quite hot in there, so I think that's probably what's causing the capacitors in there to dry out and fail, and what's causing probably the components inside just to fail in general, because that circuit board in there is going to get soaked in that heat and it's not going to be enjoying that one bit. Well, I've got a slightly different setup here now. I've actually desoldered the wires off the bottom of this LED board and I've soldered them onto this one and put them on a heatsink. And this way these two are actually thermally isolated from each other. And the reason I've done this is because I want to see if the circuit board itself actually generates any kind of significant heat on its own without the LEDs. So same thing again, I'm going to run it for about 2.5–3 hours and we'll just see what we get. Right, so it's been about 3 hours, so slightly longer this time, and the temperature has settled to about just over 26.5 degrees. So the circuit board is obviously not generating any kind of significant heat, and if I actually touch that now, it just feels barely warm to the touch. I can't really tell, to be quite honest with you. This one is obviously quite warm because of the LEDs, but this one, yeah, barely feel anything there. So it looks like it's the LEDs that are actually generating pretty much all of that heat that gathers up inside there. Right, one last thing I want to do is just a question of safety really. I just want to check the isolation on this little power supply. So I've shorted the outputs together and I've shorted the inputs together, and I've got my mega. I'm just going to mega between the input and output and just see if it passes. Now this isn't an official test or anything, but it'll just give me a bit of peace of mind. At least I know it's good. Now, so we'll switch our instrument on, and I'm going to start off on the 250 volt scale, and we'll just test this and see how this goes. Yeah, so that's fine, that's past that, so we'll knock it up to 500 and we'll test that. Yep, that's also good, it's past that, so let's step it right up to 1 kV and we'll try that. It's a little warning beep there to let us know there's 1000 volts on the probes. Yep, that's fine, that's past that as well. I kind of knew it would, but I just wanted to sort of test it really for peace of mind. So one last thing that you should really do, because this will catch you out every time, I'm just going to short the probes together and quickly do the test again and just make sure it's 0. Yeah, that's fine. The amount of times you see people use these things and they've got a loose probe or something and they actually haven't tested anything at all. Pretty embarrassing. Anyway, there we go. So there you go, not exactly brilliant. I mean, they're not terrible as a lamp, but it'd be great if they were a bit more reliable because, well, let's face it, that's what you want from a light bulb, isn't it, really? Now, I did look online and I found this exact bulb and it had like a 1.5 out of 5-star review. Many people complaining that they've had to return them several times because they keep burning out. So it seems like these are just an unreliable lamp. Now, while I was online, I had a quick look around and I discovered there are others that look pretty much identical to these ones, except they've got a lighter coloured heatsink on them. And those ones had a 4.5 out of 5-star review going back about 2 years. So them ones seem a little bit more reliable. So I've actually ordered one of those, and when it arrives, I'm going to tear it down. We're going to compare it to this one and see why that one is possibly more reliable and see what the major difference is between the two. So there you go. I hope you've enjoyed this one, and if you've got any constructive criticism or any questions regarding this, bung it in the comment section below and I'll put any relevant information in the description. So there you go. Thank you for watching. Nice one.